ではそろそろお時間になりますので、次のセッションを始めさせていただきます。次は岩木真嗣様による、データコレクションアナリシス&オプティマイゼーション with Python という題目でお話ししていただきます。どうぞよろしくお願いいたします。
皆さん、こんにちは。I speak in English. Hello, everyone. My name is Shinji Waki, and actually, there's no reason I use English here, but you know, I just wanted to practice English, so I chose English. Who don't understand Japanese? Many. So I will try. I do in English, yeah, and maybe sometimes I mix Japanese. But please be patient with me. This is, yeah, a part of my practice. So today, I'd like to make a talk session about data collection, analysis, and optimization with Python. Okay, so first, as I said before, my name is Shinji Waki. I'm a system engineer working in Kozo Keikak Engineering. And I belong to the operations research department. So I develop optimization software and so on. So my profession is more data optimization, not data analysis. And my Python experience is 1.5 years, not so long. But I like it, so I came here and wanted to make a talk session. So motivation, why I wanted to make this talk session is, okay, the upon flow of problem solving with IT. So if you want to solve some problem with IT, you have to go through this, flow. At first, you have to collect data, then pass them, then analyze them. And after the analysis, you can decide what kind of optimization you can do with the data. And after the optimization, you visualize it. And maybe some employers can easily understand and apply it to their business. And anyone ever heard of George Bernard Danzig? Okay, not so much. He's the father of linear programs. Have you ever heard of linear programs? Linear programs. He's the father of it. And he said the time when much larger problems must be solved is not far off. We have to research solutions for large-scale mathematical programming problems. Yeah, he said that. This is, I think, really far past. And then the next guy came. He's Robert Bixby. Robert Bixby is the founder and developer of the software called Groby. And Groby is a solver. And solver is a software to solve LP problems, linear problems. And he said, in the past 15 years, computers got faster by 3 orders and algorithms also by 3 orders. So together, 10 to the 6th. Our optimization software, Groby, can be used to any problem in the real world. And it's true, Groby is now used for scheduling the football scheduling in the US and NFL, I think. And yeah, optimization can be used to really big problems. On the other hand, here I come. And I say, okay, I can model and solve a large-scale problems because my profession is OR. But thanks to Danzig and Bixby, but it is, however, not enough to make my job comfortable. Because obviously, if you want to optimize something, you need to collect data, pass data, analyze data. So before going to optimization phase, we must go through several laborious steps: collecting, passing, and analyzing data. And you know, before coming up with the Python, I was doing everything in C#, and I really didn't like it, and I wasn't really good at collecting data by C#. But I found all the steps can easily be learned and executed with Python. So I just wanted to share with you. Yeah, so today I talk about the let highlighted parts, collect, parse, analyze, optimize. Here, sorry for Japanese, but this is the flow, and I listed some libraries you can use for each step. The upper one is data collection, PyODBC. This lets you easily connect to the any database, and of course there are many API, web API, TweePy, Google Map. You can easily get the data from Twitter and so on. Yeah, and when it comes to analysis, NumPy, scikit-learn, SciPy, Pandas, StatsModel, and NetworkX. NetworkX I will also demonstrate today. NetworkX is the analysis tool for network. And also the lower one, site optimization and simulation. Pulp is the wrapper for a solver. I will show you later. And SciPy, I just want to skip. SymPy is for the simulation software. And of course, you have some visualization, Matplotlib, Bokeh, NetworkX can also visualize the network. So this is what, okay, so why data analysis is important for optimization? Let's think about you have a big data regarding a demand for certain goods. If you can analyze them very well, you can predict the future demand. And if you have a reliable, precise future demand data, you can optimize when and how many goods you should order. So data analysis is very, very important to before going to the optimization. So now, let's go one by one. At first, I'd like to explain how to collect data from the web. Today, I want to focus on the web. What the libraries you need is request, Beautiful Soup for, and if some JavaScript is included in the pages, you can use Selenium library. This one doesn't appear today, so just forget. Have you, anyone has ever experienced data collecting, parsing from the web? Okay, yeah. But I will explain. So, so I think I don't go too far. I don't explain in detail. Here you see what you need for web page scraping, PS4 requests. And if you are really beginner in Python, I recommend you should install Anaconda. Anaconda includes almost every library like Beautiful Soup and request, and also pandas and so on. But let's assume that you have already installed everything. And today, the page we are going to scrape is kakaku.com. Surprisingly, in kakaku.com, there is a TV program list from now to the past, I think, 6 or 7 years ago. So you can get many, many data about TV program list. So you see, this is 4 channel, Nihon Terebi, from 23. These talents appeared on the TV. So what I want to do is who appeared the most in the past and so on, and who are deprived of chance of appearing in the TV, like maybe Minomonta, I think. That could be a good example. So, so this is a basic for Beautiful Soup. Actually, you can do anything if you can use requests get method, and also Beautiful Soup find all method, attributes get method, and get text method. This is everything you use for this scraping. And actually, for other pages too, you can do almost everything with these 4 methods. So at first, I didn't import requests. Okay. So at first you say requests get, then it gets HTML object, then you give it to the beautiful soup, and this is the object. So you type like this and get text member and give it to the beautiful soup and create soup object. If you execute that, no module. Why is it? Sorry for that. Okay, something wrong. Requests I have installed. Okay, sorry for that. I'm sorry, just now it doesn't work. So maybe I will come back later here again, but normally it works. Normally it works if you have installed requests, but now, sorry, it doesn't work. So anyway, what I do is crawling and scraping the data from these web pages. And here you scrape a page over a certain page and append to the results. And this outputs, okay, something many wrong. Okay, now, anyway, let's assume that you get all the data from the web. And actually, I already outputted it as output and CSV. Here it's written test and CSV, but I have, output modified CSV. So sorry, maybe I come back to the web scraping later, but now let's go to the data analysis phase. So analyzing data, you can use libraries pandas, scikit-learn, and statsmodel. Who have ever used pandas? Many, I think, yeah. So obviously you have to import pandas as PD. Then you can use read CSV method to read out modified CSV. Oh, this works. I'm using Python 3. Okay. So let's see. Let's see the content of data. Yeah. So for foreigners, sorry, you cannot use read Japanese, but here you see a channel for date 2008-0801 and date detail, including the time span, and also the title of the TV program, and also the members appearing on this program. So we use this data frame and play around with it. So now, data, we don't need this date specific one, so we just drop it, and we make new column called dtime, and we can use toDateTime method. You just give it date, and you give format, then dtime becomes type of time. And also I drop some NA, and finally making new data frame, choosing the law which contains Mino-Monta, okay? Yeah, so that's done. So now the time to visualize it. Let's see. Here you see T result is the result for all the channel, and T6 is a result only for TBS. And if you see that, here you can see almost TBS is dominant for Mino-Monta, and I don't know why, but it's suddenly decreased. Let's see. It's very fun to see that. Let's see. Hatoyama-san, this is also very, very fun. I looked up, and he was prime minister starting from September in 2009 to July 2010. Okay, complete match. So that's you can play with. And I also did some other analysis too. I just wanted to find out some factions in comedy venues. So that's completely out of idea, I think, for foreigners who don't know well about talents. But just I don't get into detail. So I did some k-means clustering. And you see Habat's tunnels. This is a group of tunnels. Beato Takeshi tunnels, of course, Canning, Banana Man, Ogiahagi, Ariyoshi, and it's, it matches to your instinction, yeah? And these guys doesn't belong to any group. Samma, Ucha-Nanchan, Samas, yeah. So what I want to say is it's fun. So here I do some association analysis. This takes a long time, so I don't go further again. So finally, let's go to the optimization phase. Have you ever tried optimization? No? LP? Okay, not so much. It's not so popular yet. So libraries you need for this section is Pulp. You can install it with pip install Python Pulp. So let's get to the basic of how to use Pulp. Solving knapsack problem. So what's knapsack problem? It's written here. The knapsack problem, blah, 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 blah. I don't want to read, but let's see the example. There are several files with different size. Some size are 30 megabytes, some size is 60 megabyte, and so on. And you have one CD, and the capacity is 600 megabyte. So you want to achieve write as many files as possible to the CD. So if you can write the files of 600 megabytes to the CD, that's optimized. That's the best answer. So to solve the problem, first you have to formulate a knapsack problem. And as you see here, this is the formulation. I is the data, and SI is the size of a data, and VI is a variable. And if you want to put a data I into CD, then this one becomes 1. If not, this one becomes 0. And also you need some constraints. The sum of the sizes should be lower than C. So now let's say CDR size is 600, and files with sizes is like so. And at first, what you have to do is to define LP problem, knapsack, and say LP maximize. This time you want to maximize the objective function. And also you have to define the buoy, this one, and say you have to name it. And also buoy only takes 0 or 1, so define as LP binary and make this variable for the by this number. And this is objective function, and this is constraints. So it's really easy to write. What you do is just m plus equal lp.sv. This is objective function. If you want to add constraints, mp plus equal lp dot, and then you do some lower than or larger than or equal. So that's the formulation, and that's done. It's done. And finally, you just do msolve. And you get the answer, optimal 600. And the pair to be chosen is this one. So this is very easy to do. And actually, I wanted to apply this one to the TV program. If I can get the audio rate for each program, and if I can get some fee for each talent, by using this problem, people can come up with, okay, I have a budget of 1 million yen, and I want to make my program as much. I want to get as very high audience rate. Then who should I choose to appear? But there was no data like that, so I gave up. So that's the example of LP problem, and why not trying again the requests? Maybe I didn't install requests. I think so. Pardon? Dates times? Okay. You want to know the what date time means? Okay. Again, requests? You know, I'm not used to this kind of presentation, so okay. But to be honest, scraping is not so fun. So yeah. So if you see print soup, you can get the contents. Oh, thank you. Thank you. Oh, thank you very much. Yeah. Actually, I was using URL lib at first, so and I changed to the request, so maybe I forgot installing the request. Yeah. So here is the basic soup find all A, and let's see here. This is the, I think, easiest way to extract all the links in one page. You know, you get soup find all A, then it finds all the tagged A, and you see link attributes and get ref, then you can get the URL. So with this one sentence, you can get all the links. And this is not fun part, so try it by yourself, okay? Yeah. So my time is running out. Does anyone have any question? No? Then I will continue.
Thank you for talking. I have a question about data store. You talk about analyze or optimize data store. Data flow. But I think you should need data store. How about do you think data store?
Using data store is if you have very, very big data, you cannot do it within your local computer, so you need data store.
Local environment.
In local environment?
Environment, yes.
I need a data store.
Okay. Do you need a data store?
I'm not sure with the definition of data store right now. So, data store?
You collect some data from web, and where do you store?
Actually, I always store it as CSV file. I don't use any database.
Okay, thank you.
But when it comes to really big data, maybe I have to think about it. Actually, I also write a Scrapy in my presentation, but I have never used it. Is it, yeah, fun? And it's much easier to do. I will try.
So you showed the demo of the solving the knapsack problem, but how large can you solve with that library? I'm very curious.
Pulp is actually a wrapper of solver. So what Pulp does is to create a LP problem, and after that, it slows to any solver. So if you choose Groby to use, Pulp can throw it to the Groby too. But by default, Pulp has CBC solver. So just install Pulp and you can start with optimization. You don't have to install any solver. By default, it has.
Thank you.
But I found that CBC and Groby is, my experience, there's no big difference between, CBC is free, Groby is more than million yen, so anyway.
Thank you for the good, good presentation. The PUB, I understood, and PUB is a very good library for the LP problem. If you know the March March minimum problem, so do you know the good solver or good library with Python?
You mean you want to use some meta-heuristic method? Okay.
So
there is one GA algorithm library for Python. I know that. And some SciPy also has some meta-heuristic algorithms. That's all actually I know. I don't use any library for meta heuristics.
Oh, really?
I do by myself.
Mhm.
So yeah, that's my answer.
Okay, thank you very much.
じゃあそれでは時間になりましたので、これでセッション終了させていただきます。じゃあ拍手の方をお願いいたします。どうもありがとうございました。
Thank you. I'm very sorry for wasting the time, and thank you for your patience. Thank you very much.